Hi students, let's look at this question here, which is to find the shortest distance between two skew lines. So you're given these two skew lines here and you're told to find the shortest distance. I think that what we need to, there are two methods here. I could think of two. One is without finding the points of P and Q. Oh, actually there are three. Ways. But I think we're just going to do two methods, okay? Because I think generally what you need is um, just these two, and that's about it. So the first one will be using magic triangle. The other one is to find the points P and Q. Then after that, you find the distance P and Q. So let's see how we can do this. Now we try to understand the question here. You were given two skew lines. Now it's good that if we are able to draw these two skew lines out. So this is what I draw. I'm gonna draw the two skew lines on plane because it's gonna be easier to see there. Then what we have L1 here. Then this is L2, right? Now what we're gonna do is, as usual, just label up the points. So just let point this be A. Let A and B be points. Minus 1, 1, 3, and 1, 3, 2 respectively. So this will be A, and that will be my B. Okay. Now I would say, okay, let's say we just put B around here. I think here will do, yeah, B better. Now then after which what we have is this is D1 and this is D2, just like normal convention that we usually do, the direction vector. So this case here we just draw this as D1 and this is, say, this is D2. Now when you want to find the point which they are shortest distance of both of these skew line here, the line that you're looking at is actually this line here. You could imagine both of which would be 90 degrees to each other, right? So it's about somewhere here. So I'll just draw it out here. All right. The special property about this line here is that so P, this is P, this is Q. This is 90 degrees and this is 90 degrees. Okay, but they are slight. The 90 degrees is a bit off. Okay, so that is the main thing. So off you go. You have got two ways of solving this. At least we are going through these two methods, but the third method requires another cross product, so I'm not very interested to do that. I think the first method is straight up use magic triangle. Okay, use of magic triangle. So this is without finding P and Q. Okay, so this will be very convenient because what you need is just the distance, right? So you just do that by doing the first method here. Now this case here, you could actually see that PQ, okay, PQ is just because it's perpendicular to both D1 and D2. So to take it PQ, the direction, the PQ will just be D1 cross D2. Okay, so you just take, because you see that this is D1, then this is D2, D1, D2. So maybe I just put this like, this is D1, this is D2. So you cross it, you get P. That is the first one of the characteristics there, if you are able to see it. Okay, so then what we need to do next is actually just find PQ. Once we have PQ, the distance that we want to find is we just take the projection length. The shortest distance will be the projection length of AB onto P. Okay, so you think about it. Shortest distance would just be projection projection length of AB onto PQ. So this case here, not an issue. I think what we can do is just AB, because you're taking AB and then this is PQ. Okay, this is AB. Then this direction here is PQ. You project it, this would just be AB dot, right? Because magic triangle AB dot PQ unit vector is quite straightforward, I think. So this case here, what you can do is just AB dot with PQ modulus PQ here. I think both methods will probably require you to find PQ. I think first, do I need to find PQ for the second one? I don't know. Maybe not. I'm not sure. Let's see. PQ would then be, we're just gonna find PQ. PQ, PQ would just be this dot with this, right? D1 dot D2. So take D1, which is minus 221 cross with 316. This over here would then be 1115 minus 8. Okay, so this is a dot product. So what you get is A to B will just be A minus B. Okay, so it doesn't matter which, whether it's BA or AB. You can use either, is fine. So that will be 2 minus 1. This will be 11, 15, 18. Just square root this. I think that's it. We get the answer already. Okay. So later on we talk about the second method, which is also what is required of you. Like you have to know the second one as well. That will be 60. I'll use the second method to check my answer. Okay. Over here will be 410, square root 410. So I think I'll just rationalize the denominator. I mean, you can leave your answer in this form here, not an issue. So what we're gonna get is 112 over 410, 410. So I think because it looks very ugly as a as a denominator, so I'm gonna do this, and that will be 25 over 205, 56. Units. Okay, that's it. So for method 2, I think what we need to do is just use dot product. So method 2 will require us to find P and Q first. But just using normal dot product will do. Okay, so method 1 will just find the distance straight by using magic triangle. For this case here, what we need to do is just basically find out what is the point. So we know that P is on L1, right? So for some lambda real value, P is on the line L1. We can let P be the equation of this line here, and then we do relay. So OP will take the line equation because we know that there's a lambda which corresponds to that point there. Always see this lambda as a housing address. It's like if you're given you this lambda, you can tell which point it corresponds to on the line. So for some lambda mu real, for some lambda real value, we know that OQ is also 132 plus mu 316. Okay, so that's it. Now what we need to do for this case, I don't think we need to use cross product. We just need to find PQ. So PQ will just take this minus of this. This is minus 1 minus 3 plus lambda minus 2 to 1 minus of the whole thing. Oh, sorry, I should have used Q minus P, but it doesn't matter. So I'm good because just be technically correct. This case here, what we did is plus mu 316 minus of minus 113. Okay, they just minus both of it up. I think should be fine. So this minus of this will be 2 minus 1. Then that will be lambda 2 minus 2 minus 1. Now once we're done, we can straight up know that PQ dot with D1 is 0 because it's 90 degrees over here. Then we also know that PQ dot with D2 is also 0. Okay, they are 90 degrees on both ends. So what I'm going to do is actually just dot them. I think you get two simultaneous equations, you solve it, you're supposed to be able to find P and Q there. Once you've done that, that would be it. We are able to then solve the so D1, what's the D1? D1 is over here. Minus 2 to 1, it was 0. Then D2, there'll be 2, 2 minus 1 plus mu, 316 plus lambda, 2 minus 2 minus 1, a dot with d2, which is a 316. 316 equals to 0. Okay, now we're going to just expand everything. So dot them, get two simultaneous equations and solve it. Okay, I'm going to just write it. So when you do a dot product here, you don't really need to expand. You just take this and dot with this. So 2 minus 2, negative 4, minus 4, minus 1. Then you just dot everything up, you get all these. Okay, I'll just do the same for both. Then this will be two simultaneous equation. So minus 2, yeah, there you go. So there you go. Once you get it, so you solve 1 and 2 simultaneously, what we'll get is actually mu equals to negative 11410. It's very what do you call it, promising, because 410 is what we get for here, but I'm not sure whether this, but we never know. What we're going to do is actually just sub back and find out what's the OP and OQ, that point there, by substituting back. Then after it, we just need to find PQ, the length of PQ, by finding PQ. Okay, so OP will just be substituting lambda in to the line equation there. OP is equals to minus 113 minus 24205. That will be minus 221. OQ would just be the other one. Substitute in the second line equation. OQ will be 132 minus 11410 minus is 316. So after keying calculator, this is my OP and OQ. So now I'm gonna just find PQ. Then the shortest distance would then be finding the modulus of this vector here. All right. So the length of PQ. So I'm gonna just proceed to do this calculation here. So this is P to Q. Now what I'll do is actually just find the length, just like that. The reason why I put the 140 out is because I don't want to put it too big. So what we can do is just 410 square root of okay, number. I try to compare. I realized that I did a careless mistake here, so I'm just gonna mark my work here. This is, I'm not sure why I got 60 here. Oh, I think because I key in calculate before. Okay, this is plus 8. Right. 22 plus 30 plus 8 is 60. That's right. So this is 60. This is 60. 60. That will be 60 over 410. That will give us 6 over 41. Okay. So this is the answer here. So be careful with some of these working. So because there are so many things going on here, so I make a mistake here. Okay, I'm just gonna just okay. So I make a mistake here as well. So I check, because both of the answers should tally, but I did careless. Okay, so I'm gonna just change everything up so that you can just go to the website and refer to the corrected ones. Okay. So after fixing my mistakes there, I finally got the answer. That will be 14760 over 41 square, and the keying calculator, that will be this is 360 over 41. So similarly, 360 is 36 times 10, right? Over 41 is 6 root 10 over 41. Okay, so if I were to do the same trick that I did just now, this is root 14, 6 over 10, 6 over 41. So rationalize it. That will be, okay, so both will give you the same answer. So it's good that we have two methods to check our solution, right? Okay, so just take note, method 1 will definitely be faster, because you don't really need to find P and Q. You just use the magic triangle, the projection method. Then after which, for part 2, if you're required to find P and Q, then maybe I guess this would be better. All right. So that's how we do this question in proficiently. If you have any questions at all, please let us know, and I'll see you in the next question.